Start recording. Glory Alex, can you check whether this link is working?
Okay, sir.
Yeah.
Yes, sir, it is working.
All right, thank you. Where are the others?
I think they will join. Once I will inform in groups.
Oh, is that so? Is that how it works? You inform and then they will join.
They will join, sir, but I don't know why they are not joining till now.
Okay, okay, fine. Sure, no problem.
Once I will leave a message in groups.
Yeah, please go ahead.
Okay.
Morning, Bhubesh Gupta. Okay, good morning everyone. So I think most students have joined.
Good morning, sir.
Yeah,
Good
morning.
morning, sir.
Morning everyone. So the class is already being live streamed and it is available on the link that I am showing you right now. The okay, I am sharing the link also. Right. So we have around 14 students have joined so far. I and Guruvishar, Abhishek Kumar, Afrit, Akash, Anshika, Bhupesh, Prince Glory Alex, Dheeras, Karthikeyan, Krishna Swaroop, Mathod Nishant, Malot Nishant, Mut Praveen, Prajwal, Venkatesh, Shubham Joshi, and Vishesh Nagar. Okay, so we were discussing about class in the previous classes and objects. Okay, so we discussed about classes and we also discussed about how to define classes and how we can inherit classes, etc. Okay, so if there is a class A, then I can inherit class A into another class B. So I can say class B and in bracket A, which means that B inherits A and B will have the attributes and methods that are associated with A. Now, when I say this, what comes to your mind? That whatever we have learned so far, right, is just about the syntax. It's just about the syntax and the basic concepts regarding inheritance, polymorphism, encapsulation. Those are the things that we have learned. So we have learned OOPS concepts and syntax. Have we really learned to code? I would say no, because coding, right, is not just syntax. Coding is not just syntax. Okay, it takes experience and knowledge to make programming easier and maintainable. All right, so this is very important, and with this in mind, I have to tell you few rules that are pertaining to classes. If I do not tell you this, right, then the problem is that it won't be complete. The learning about classes, of course, I wouldn't say that even if you just go and read this once or twice, you will learn classes and objects completely. No, it takes years of experience, and this particular website wiki.c2.com is actually a software engineering wiki, and this is actually being maintained by a lot of people who are well experienced and are working in the software industry. So let's say I will tell about a person called Martin Fowler. So he also can be found on the C2 wiki, if I am right. Yes, so you can actually just search for Martin Fowler on wiki C2, and you will get more details about what who this person is and what are his contributions, etc. So that is the reason. So the reason why I told you about this wiki.c2.com is that because it's a software engineering wiki, and if you go in there, you will actually get to read a lot of things. So one such thing that I want to actually quickly show you when I tell you about classes. So when it comes to classes, I asked you this question: have we really learned to code with object oriented programming? I would say. Okay, so until and unless we understand these rules and things, we won't be able to write good code. So good code means that code which is maintainable, which can be read by another person, understood by another person, and can be modified and add features by another person who has not been part of the software construction. All right, so in the classes, you have something called one responsibility rule or single responsibility rule. Okay, so classes, interfaces, functions all become large and bloated when they are trying to do too many things, right? It's a very simple thing that we are trying to explain. So yeah, I'm in class. Yeah. So classes, interfaces, functions, all of these things become very bloated, right, when we are trying to do too many things. And so that is why it is very important that we try to assign one single responsibility to a particular function or one single responsibility to a particular class. Okay, which means that you do not want to make the function or the class bloated and get confused with the responsibility or the things that it is supposed to do. Okay, so it says to avoid bloat and confusion and ensure that the code is truly simple, okay, we have to practice code normalization, which seems to be a variation on once and only once, and also do the simplest thing that could possibly work. So you can see that these are all links to to object oriented programming concepts that you really need to understand. Okay, I wouldn't say this would be very important for the Python programming class. Okay, in the Python programming class, we have actually learned the classes and objects as part of the syntax, but I would not say that learning just the syntax would make you a good programmer, or you would understand what is to be done. If I tell you class A, class B, class C, class D, you will just simply accept all of those things, saying that ये क्लास है और क्लास A का अंदर एक फंक्शन है, वो A डैश है और A डैश डैश दूसरा फंक्शन है और एट्रीब्यूट है A attribute 1. Okay, so if I tell you something like this, if I give you a code like this, you would accept it. But if I ask you, what do you understand from that? You might try to tell that here we are defining a class A, class B, etc. But you will not be able to explain the physical significance of that particular code that I gave you. Why? Because I have used class A, class B, A dash, A dash dash, A note, etc. as the function names and the class names, which has actually no physical, real world meaning. Okay, so when it comes to designing the object oriented programming or the softwares, you need to make sure that you design it according to the real world. So that is where we say that we have a person, and that is a class, and from the person we have an employee, who is employee is a class of a person but with slightly different attributes. Okay, then you may have another kind of person, okay, and different things. So which means that every class should actually be there to represent a real world entity, which means that if there are 2 or 3 or 4 or 5 classes, then each of these classes, these 5 classes, should in reality be representing one real world entity, and the interaction between these classes should be such that it is real interaction that happens in the real world. Okay, so this is what we start with the one responsibility rule. I'm going to send you this on the chat window. Okay, so I want you to go through this particular C2 wiki, read a little bit more. Of course, this particular C2 wiki, right, I have just introduced this to you. If you have further courses like software engineering, if you have further courses like object oriented programming that you have to learn in the next semesters, we will be actually going through these in more depth. Okay, so that is the single responsibility principle or the one responsibility rule with regards to constructing a particular class. So we know that a class should contain should have the smallest responsibility, or it should have just one responsibility. Okay, that is how it should be designed. And then another thing is tell, don't ask. So I told you in the previous class that when we were learning classes, it is not a good thing to read the state or read the attributes of another object and then make a decision at your end by yourself. So this is what the tell, don't ask principle with regards to the object oriented programming is discussing. So the tell, don't ask, it says very short summary. It says it is okay to use accessors. Accessor means any function or any you can say that it is like object A dot attribute 1. Okay, so you are actually reading the value in the attribute 1, so that is an accessor. Okay, so any statement that is used to take the value of a particular attribute. Okay, so it is okay to use accessors to get the state of an object as long as you don't use the result to make decisions outside the object. Okay, so any decisions based entirely upon the state of one object should be made inside the object itself. So this is what the tell, don't ask principle says. Okay, so if you read up a little bit more on the first link that is given over here, it's a PDF file that is given over here as a link. Okay, so it says about the software construction and task. So it says a distinction to object oriented code or code written in that style in any language is the idea of issuing a command to some entity to get something done. You see this explicitly in languages such as Smalltalk and Ruby, where method invocation is viewed as messages being passed between objects, not as function calls. Okay, so see, when it comes to object oriented programming, whenever we invoke a particular method, okay, it is viewed as messages being passed between the objects. So there are two objects or there are three objects and they are interacting by passing messages with one another. So this is the idea with which you need to approach the object oriented programming paradigm. Okay, so not as a function call. So it need not be thought of as a simple function call, although programmatically it is just and syntactically it is just function call that is being actually done. But in the object oriented context, we say this is as a message passing between the different objects that those are interacting. Okay, and then it says about the idea of demeter, okay, and certain other things. So in this one there is another example for the tell don't ask. Just let me just see and figure it out. Just a second. Right, let me just read it. Procedural code tends to get information and make decisions based on the information. Object oriented code tells objects to do the things. That is, in the model we want to follow, you send commands to objects telling them what you want done. We explicitly do not want to query an object about its state, get the value, right, make a decision outside and then tell the object what to do. We don't want that to be done. Okay, this is against the tell don't ask law. Okay, so if we do it this way, right, that starts to sound a bit like the gossipy neighbor and not something that the shy code could do. Okay, so there is an example over here. Okay, so consider the story of the paper boy and the valet. Okay, the paper boy and the valet. So suppose the paper boy comes to your door. So let me make it a little bit bigger. Suppose the paper boy comes to your door demanding payment for the week. You turn around and the paper boy, okay, this is interesting, and the paper boy pulls your wallet off your back pocket. See, the paper boy, the newspaper boy has come to your house and is asking for the payment for the week. So you just turn around and you have your wallet in your back pocket. So the paper boy just tried to grab the wallet and takes the money and puts the wallet back. How absurd would that sound, right? So the paper boy pulls your wallet out of your back pocket, takes the $2 and puts the wallet back. As absurd as that sounds, many programs are written in this style. So this is why I have taken time to introduce you to this particular concept, because as budding engineers and as engineers who will be trained after 4 years, who will get your degree, right, I do not want you to go out somewhere and say that classes are just some way to define inheritance, polymorphism. No, it is about designing and modeling the real world interactions between the different objects and items or the things that you can actually see. So you need to observe and you need to model them like that. Say for example, very simple, when it comes to robotics or when it comes to some kind of things like that, right? When you want to design the best robot, how would you design that? You would observe the animal whom you want to mimic, and you would slowly make it better and better over time and make it as real world and as real as possible. Okay, so in this particular paper boy and the wallet example, you wouldn't want the paper boy to come and pick your wallet at his or her will and then take the money and then return the wallet to you, because it is absurd. And as absurd as that sounds, many programs are written in this style. which leaves the code open to all sorts of problems and explains why the paper boy is now driving a Lexus. Okay, so instead of asking for the wallet, the paper boy should instead tell the customer to pay $2. Code should work the same way. We want to tell objects what to do, not ask them for their state and then tell them that you do this. Okay, so adhering to this notion, we have something called tell don't ask. Okay, so this is tell don't ask, and so I'm going to send you these links. I hope this kind of gives you the intuition that writing programs is not just mechanical work, right? It's an art. It's an art. Definitely it's an art, because you have to actually program and model and write down in code the real world things that you are saying, and then you will actually model the interactions between them, and you will create the methods and attributes in such a way that it all makes meaning. So when you write a program, and when you have written a real meaningful program which can be easily understood by another person, say that if there is a class human, and if there is a class called fox, if there is a class called lion, you know that the fox does these actions and the lion does these actions. So if everything is modeled correctly, right, another person who is going to work on the code that you have given to that person will be able to simply understand how the interaction has been modeled and will be able to quickly do it. While if you give a code which contains class A, class B, class C, class D, and no real world interactions between them have been modeled in a proper way, then it won't be helpful. So yeah, so that is those are the three things that I just wanted to tell you, and I want you to go and read up about the law of Demeter. Okay, so it says only talk to your immediate friends. Example, no one never calls a method on an object you got from another call, nor on a global object. So as an example, it's written over here. So one should not have a chain of messages. Okay, so if you have an object A and you have another method get B, and then this returns an object, so you have A dot get B dot get C dot do something. Okay, this kind of lines in your program should be avoided, and that is what the law of Demeter says. So one should not have a chain of messages in some class other than A's class. Okay, so this is what we mean by the law of Demeter, or only talk to your immediate friends. Okay, so I've sent you the links for these basic things. Now I want to switch focus to another topic, so I am going to say the class is done. Although I mentioned in the previous class that classes and objects are done, I again thought about what is the topic that I might have left behind, and I really thought about the topics like tell, don't ask, one responsibility rule, and it is very important that you understand it at this stage in your education and your career. Okay, so next is something I want to tell you and teach you. So there are two topics that I want to teach you. Let's see what are the topics. Okay, so one is related to graphics, and one is related to images. So graphics means related to drawing. Okay, there is a subject called computer graphics. Okay, which essentially discusses about how to draw shapes and objects on a computer using pixels, okay, or using the smallest using, okay, on a computer. That's what I would, that's where I would stop. Okay, that is related to computer graphics. So graphics, and this is where we learn a topic called turtle. Okay, turtle is a simple package in Python that lets you draw patterns, color, and do other things. Okay, color and color, graphics, etc. Okay, so this is turtle, and this is a turtle is also a a beginner level programming language that is used to teach kids programming. Okay, so it's like, you have a turtle who will go forward for 50 steps, and when going forward for that 50 steps, the turtle will leave a trail. Okay, and after taking 50 steps, the turtle may want to turn right. Okay, now the turtle moves 40 steps down to the right, and then after moving 40 steps to the right, the turtle may want to stop and move back for 50 steps. So it can go anywhere. So that is the turtle. So it's like how you can actually control the small turtle's movements and then get your patterns, colors, and graphics drawn on the screen. So that is the turtle graphics package. Okay, so that is related to computer graphics. That is the first thing that is related to graphics that I want to teach you. And next thing is something related to images. So images, what do you mean by image? So let's assume that I am in a fighter jet, and ahead of me I can see an object which is flying at a very high speed. Okay, I am a fighter jet pilot, and ahead of me I can see an object which is flying at a very high speed, and I notice that it is an enemy aeroplane. Okay, and I need to shoot it down. So how do I shoot it down? So what I do is I have a control panel on which I have a launch button. Okay, and before the launch button I have a small probe which I actually turned towards the object which is traveling towards me. I focused towards that object, and then I locked that object, and then I press launch. Now no matter what, where the object goes, so it can change its path in the air, in the mid air. When it is moving towards me, it can change its path depending on the obstacles that the object may have in its path. Okay, so but my launch button, when I clicked on it, right, it also has to destroy the target object, the enemy object, and the enemy object can move its path. So how do I do that? I have a computer system which is going to now track the locked object. So no matter where it goes, it is getting tracked. Every movement of the object which I have locked now is getting tracked, and ever since I press the launch button, right, the missile that I have sent to the enemy object is actually moving in such a way that it is following the object, and no matter where the enemy object goes, my missile also follows it closely until it destroys it. So how is that done? So I was saying about a enemy object and missile to destroy it. we did image processing and object tracking to follow the enemy object and to reroute the missile so that the target is hit. Do you guys follow what it is? So one is about drawing on the computer and another thing is about looking at a video or looking at an image that is taken and doing some processing based on that. Okay, so one thing is about drawing, computer graphics, and another thing is about images. So these are the two things that I want to teach you. So let me show you curriculum. So CS151. Okay, so these are the things that I am discussing. Simple graphics using the turtle module, simple 2D drawing, colors, shapes and digital images and image file formats. Okay, and image processing. So next is image processing. Image processing contains simple manipulations with image module, convert to black and white, grayscale, blur, etc. So these are the two things that we will be learning. Of course, we won't be we won't be clicking the launch button and launching a missile. We will be learning how we can actually get the values of the the color of the missile or the color of the object that we are tracking, and how do we how can we convert it from a colorful image to a black and white image and such kind of things. Okay, so just beginner level things. So computer graphics and another thing is images. So going to computer graphics, I'm sorry, not computer graphics, but I'll start with images. I'll start with images. So when I search for binary image, okay, on the Google images, I got an image which looks like this. Okay, so this is an image which is like a matrix, right? It's a matrix which contains like how many rows? 1 2 3 4 5 6 rows and 1 2 3 6 columns. So there are 6 rows and 6 columns, and each cell in the matrix contains some value 0 and 1. Okay, so essentially what we need to understand is that is how an image is essentially represented. Okay, an image is essentially represented this way. So let's take a look at the next image that is over here. Okay, this is the image. So here we have again a 6 by 6 matrix, and what we see over here in this image, we see a black cell, right? We see white cell. So each small block, each small cell over here is called a pixel. Okay, so let me just show you SM pixel. Just a second. Okay, pixel or picture element. Okay, so a picture, whatever picture that we see, right? Let's say, let's go to iitt.ac.in website. Over here we see one picture, right? We see another picture, we see another picture, we see another picture, another picture, another picture, another picture, another picture. We see so many pictures, right? Now let me just copy the image location and then go to this particular image. So I went to this image what are the things that you can observe? This image was taken by a camera, okay, and it was focused. Just a second, guys. Can you hold on for a second? You made it by online? Online. Okay, okay. And I'm also making it to HOD. Okay, okay. Just want to discuss. I will be free after 11. After 11. Sure. 15 minutes, right? Yeah. Maybe not. Maybe I'll take 20 minutes. Right. Yeah. No problem. Yeah. If you want to be, otherwise you may use. Oh, no issues. It's up to you because you have come for just arranging it. And even I have done this before I joined my direct work. No problem. I take an online meeting. So I can understand how it is. No problem. So I'm not able to meet. I'm taking online meeting with you and we can discuss. Yeah, sure. So when are you planning to be here? Probably 31st somewhere around that. Because that's the opening. Sure. I'll probably come here. Yeah, sure. Sure. So before that, if it's possible, we can make it online. Yeah, absolutely. Absolutely. Okay. Thank you, sir. Okay. Okay. Bye. See. Yes. Bye. Sorry guys, sorry guys, a person was waiting for me. Okay, yeah, so if you look at the image over here, right, I am going to take this image, save this image, let me main building, and let me see if I have Inkscape. Okay, I do not have. So anyway, let me tell you, if I divide these this image into rows and columns, okay, into multiple rows and columns, and I take the value of each cell, okay, I have to divide it into multiple rows and columns, and then let me show you that. Just a second, guys. Okay. So this is the image that I have just downloaded. I'm going to click on the properties. Okay, I'm going to click on the properties and I'm going to go to the image part. So over there you might have come across this particular pixels, like 982 pixels by 548 pixels. So that is the dimension of this particular image that we are seeing. So this particular image that we are seeing has a width of 982 pixels and a height of 548 pixels, meaning that there are total of 982 columns and a total of 548 rows. Okay, so which means that in total the picture will contain 982 into 982 into, oh my goodness, where did it go? Five hundred and 548. Okay, so it will contain 5,16,216 216 such cells. So it will contain 5,16,216 such cells, and each cell will contain a value, say 1 1 1 1 1 1 1 0 1 1 0 1 1 1 1 1 1, okay, and so on. So in this particular example, the white cell contains the value 1 and the black cell contains the value 0. Okay, so that is the idea with which this particular image is actually shown. So if you look at another picture, right, over the left hand side, you see a picture on the left hand side, a smiley face, and on the right side, right, if you look at the values, if you look at the number of cells, these will be the number of cells, and each cell will contain a value like 0 or 1, or it could even have a value like 0.5. okay, so this is what we call as an image. So this is what we call as an image. So image is just a representation of of something that you see, correct? So image is just a representation of something what you see. So when you look at a particular building, or when you look at a particular object, we know how we see that image, how we see that particular object. The light falls on that object, and the light is getting reflected from the surface of that object, and that is how we have the vision formed. Okay, so same way the camera also captures the light that is getting reflected by these objects, and this light and these signals are actually stored in these cells as values, and these cells are called pixel or picture element. So we have seen that in total for the IIIT main building picture that we took from our institute website, there are 5,16,216 pixels in that. Okay, or I would say what, it's a 0.5 megapixel, right? How you know about 1 megapixel, 2 megapixel, etc., right? So 1 megapixel means 10 raised to 6. That is what it is. 10 raised to 6 is 1 megapixel. So this is 10 raised to 5, right? Or this is 6, right? Yeah. All right. So these are the number of pixels and the values that you will have. Now in Python, okay, in Python you have something called the Python imaging library. Okay, it's called the PIL. So I'm going to send you this link as well. All right. So yeah, so this is the Python imaging library. Provides a general image handling and lots of useful basic image operations like resizing, cropping, rotating, color conversion, and much more. Okay, so I'm just going to save this image. Okay, I'm going to copy the, okay, let me see, I have to open it first. Okay, I don't think I will be able to save the image from here, so let me save the image from here only. Save image as, and face.png. okay, and we have something called the Python imaging library. Let me see where it has been downloaded to. Right, this is the face.png. Now yeah, we have the PIL, the Python imaging library. So you can actually import, let me just clear it, exit, yeah, and just once again I will start it. Yeah, so from PIL, Python imaging library, import image. Okay, and we can use image.open. So image.open face.png. okay, so we are going to open that particular image, and we are going to name it as so we have to, once it is opened, right, it will return an object, and we have to store that object into a variable. So let's call it as face image, face im. Okay, and face im dot show, okay, will show the particular image that we have. just loaded onto the memory. Okay, and we know that it is an 881 by 460 pixel image. Okay, it doesn't have any other information like the camera capture information like the aperture, exposure, focal length, ISO, metering, camera, any of these things. But if you have actually opened it from your if you have opened an image which is directly from your digital camera, it will have those information, and it will also have the information like where this particular picture was taken and at what time it was taken. So those are called the EXIF information. Okay, so a picture element, the cell in the matrix representing a particular color or illumination or grayscale value. EXIF information will contain the information related to the photograph. Time and date. So all this information will be there in the EXIF information, and the picture element pixel is something that is related to the smallest element, and this is what a pixel is. Okay, each cell over here is a pixel, but in reality if you look at this particular image, right, you can see that in reality this is actually an 881 by 460 pixel image. So this is not actually a 6 by 6 image, as you can see. This is just a visual representation of a 6 by 6 image, where you have 1 as the 0 0 value, then 0 1 value is 1, 0 2 is 1, 0 3 is 1, 0 4 is 1, 0 5 is 1, 1 0 is 1, then 1 1 is 0, 1 2 is 1, 1 3 is 1, 1 4 is again 0, and so on. Okay, so this is the visual representation of a 6 by 6 smiley image, which is in just black and white, which is binary. Binary means it has two states, either white color or black color. It does not have any intermediate colors. So this will be a binary image, and this will be represented by 111, 111, 101, 101, 111, 111, 101, 101, 100, 001, 111, 111. Okay, so this is how the pixels represent the values of an image. Okay, so you can open an image using the image.open, the file name. Now you know the about the relative path and the absolute path, etc. So I don't have to explain it again. Then let's just take another color image. Okay, so let's say yeah, I'll take this particular image and then save image as color image .jpg. Okay, so I've named it as color image .jpg. So if I want, I can open it as image.open color image .jpg, right, and I'm going to just call it as color underscore im is equal to open, and color underscore im dot show will show you the due to some mistake it was not shown. Let me just see whether it can be shown now. Yeah, now it is shown, and we see that it is a 350 by 350 image. Now I will do one more thing. I will import numpy as np, import numpy as np. Okay, I did the wrong thing. I should have imported a function or a attribute from this like this, but this is what I wanted to do. Now numpy has an as array. Oh, I'm sorry, as array. Yeah. So this function numpy has an as array function or an as array method, okay, which will take input and it will convert it into an equivalent array. So what I am going to do right now is I am going to look at the color image. Okay, so I am going to look at the color image and I am going to convert it into an array. Okay, so color image numpy array. Okay, so c underscore im underscore na, just color image numpy array. So c underscore im underscore na dot shape. I look at the shape and I see that it is actually a 350 by 350 matrix, but with three red, green and blue channels associated with it. So that makes it a color image. So which means that it has 350 by 350 one matrix representing the red color, and then another matrix 350 by 350 representing the green color, then another matrix 350 by 350 which is representing the blue color, RGB. So that is what makes it the 350 by 350 by 3 matrix. So that is what you see as the color image
Sir,
over here. Yes.
sir, we are having another class now.
Okay. Do you have the class on Monday?
No, sir, today is the last working day now.
Okay. So today we will have one or two more. In the afternoon we will have a few more, some more time. Okay. Or else, what I would suggest is I have some additional important work in the afternoon. So can we meet at 4 o'clock instead of 2 o'clock?
I will let you know, sir.
Yeah, sure, please. Or else, yeah, please. Okay. Thank you,
Yes,
students.
sir.
Yeah.
Thank you, sir.
Thank you so
Thank you,
much. Yeah.
sir.
Yes.
Sir, is there any guest house for parents, sir?
Um,
Arrangement of guest.
right now, Triple IT Trichy does not have any faculty quarters, any guest houses, nothing.
So we have to stay at a hotel, sir.
Triple IT Trichy does not have it. That's what you asked. And yes, you have to make your own arrangements.
Okay, sir.
Yeah. Thank you, Reviraj. Thank you so much. Bye.
Sir, what
Yes.
is the administration time in our college?
Administration time. I think it is 9 to 5:30.
Morning to evening, na?
Morning to evening. Yes.
Thank you, sir.
Yeah. Thank you, Prajwal. Any other questions, students?
No, sir.
Okay. So, students, I'll do one thing. Since you guys have to leave, you have a class. What I will do is I will not stop streaming this. Instead, I will actually just explain to you about the and you can watch it at 2 o'clock at your convenience. Okay. So the rest of the class that I will be covering now for another half an hour to 45 minutes, you can leave. Okay. But I will be covering it so that it will be recorded and you will be able to see it in the afternoon. Is that okay, Akash?
Yes, sir.
All right, sure. Thank you so much. So yeah, so those people who want to leave, you may leave. Okay. So anyway, I told you that this particular image that we see over here, right, is now a color image which contains 350 by 350 by 3. That is the shape of this matrix that you have here. All right. Now, this particular image, if you want to convert it into grayscale, you can do that. So let us try to open this particular image, okay, and convert it into grayscale, okay, we will get a different image. Just going to, I'm going to call it as BW image, black and white image, okay, and BWIM dot show. Oh my god, I think I have to close this, only then it will work, right? Yeah. Now this image that has been shown, right, is the black and white version or the grayscale version of the color image, okay. And if we do an np.as array bw underscore image npbwim nbwim dot shape, we will see that we will finally have only a 350 by 350 image, meaning that now it will not have the red, green and the blue values, but it will have only one single channel which contains the black and white values. Now if I look at the nbwim dot of 00, right, it will show me the values, and you should understand that the values ranges from 0 to 255, okay, because it depends on the number of bits that you will be using to represent that color. So usually it is an 8-bit value. All right, so you can use the Python imaging library to open an image, to convert it into grayscale, and you can also save the image using the save method to convert the image to another format. Let's assume that you have a PNG image and you want to save it as a JPG image, okay, you can do it using the dot save, and you can take a look at the particular syntax for the same, okay. So here you can actually save the file using the dot save. You can create thumbnails by using the method dot thumbnail and then passing the size of the thumbnail that you want to create, okay. Then you have you can copy and paste a particular image to a particular box, like what you see on the third image over here on the right, okay. So you can actually create a box, virtual box, and paste an image onto there. That's what you call as the copy and paste regions. Then you can do the resizing and rotation of the images, okay. You can do the resizing by specifying the size, the target size of the image, and then you can rotate the image by specifying the counterclockwise angles, okay. And then you have another thing which is not part of the syllabus, but this is something interesting. This is called matplotlib, and matplotlib can be used to plot images, points and lines, etc., okay. So you can actually plot a star by plotting the image by first showing the image, then you can use a marker. There's a red marker that is made, then a green line with circle markers. So all of these things can be done using the package called matplotlib, and it is this package called matplotlib is actually much more powerful image processing package than the Python imaging library, okay. And then I am going to quickly explain to you about a concept called histogram. So histogram means that an image may contain multiple values for each cell, right. So for each cell that we have seen over here in this particular image over here, it has a value, and if we look at how many zeros and how many ones are there, that constitute the histogram. So histogram is the distribution of the number of values in the image. So zeros 1 2 3 4 5 6 7 8, so 8 zeros are there and 56 ones are there. That is what the histogram of this particular image would look like. So if I take a color image and I said that the color images will be the values will range from 0 to 255, okay, which means that for each pixel value or for each color value, how many pixels have that value, that is what a histogram means. All right, so line number 50, about 4000 value 50, intensity 50, about 4000 pixels have that value. Value 100 and let's say 20, about 11,000 pixels have that value. All right, so that is the idea about picture or image manipulation with Python. Another thing that I want to tell you is about turtle programming, and Bhadraksh Bhargava and Krishna Swarup, are you both following the class? Okay. Yeah. So another thing I want to tell you about is the turtle programming. Now turtle programming is actually very simple, because as I told you, it is about let me import turtle. You have to create a screen with the turtle, okay, so that is the window. So we created a window with the turtle, and right, so we have created the window with the turtle. Let me just see whether I can make it smaller. Right, okay, so we have created a window with the turtle, and once the window is created, right, you can now create a turtle. Okay, so you have to create a turtle. You can give the window some background color. So let's try the background color, window.bg color. Okay, and the light green was given here, so let's give it light yellow. Will it work? Yes, it worked. We have a light yellow window, and it has no title here right now, so I can give a title, window.title, turtle window. Okay, unfortunately that has not changed. Anyway, that's okay. Now let's create a turtle, and you create a turtle by using turtle.turtle. First is we created a screen by using turtle.screen. So I'll call it as start. Okay, turtle. So now once we created the turtle, right, we can see that a small arrow has been placed in the turtle window, correct? Oh, we had given the the title to be turtle window. It took some time and it has been applied. Now it is showing as turtle window, correct? So we created a screen, then we gave it some background color, not necessary. We gave it some title to that window, and we also created a turtle. A turtle is placed at 0.00 by default, and now I can ask the turtle to move forward. Okay, so right now it is moving toward, it's showing, it's kind of pointed towards the right. So I'll do turt dot forward 100. I have not run it. Okay, and let me just make it a bit smaller so that it will be easy to see. So we have the turtle window here, and we have the turtle. I'm asking turtle to move forward by 100. So when I said turtle to move forward by 100, it moved forward 100, and it left a trail from 00 to 0100, correct? And the turtle has moved to the new place, and turtle dot, I can ask the turtle to draw a circle of, let's say, a radius of 40. So when I do that, the turtle will take a circle, draw a circle of 40, right? So this is what you call as the turtle graphics, and with I can say turtle, once I'm done, I'll do turtle dot done. Okay. So turtle dot screen, turtle dot turtle, and drawing commands, and then the done. So there are many things that you can do. For example, if you want to draw a simple square, you can draw it using a code like this. Over here you have a for loop where you move forward for a particular number of steps, then you move right at the end of the loop, and then the next loop again you move forward, again move right, again move forward, move right, again move forward, move right, and that makes it a square like this, right? So you have for I in range of 4, skk dot forward 50, skk dot right 90, turtle dot done. If you want to draw a star, you can draw a star like this, how you see over here, right? The code is import turtle, star, turtle dot turtle, star dot right, star dot forward, star dot right, star dot forward in a loop, and then you have the star. And similarly you can draw a hexagon. Okay, so practice all these programs like hexagons, stars, and all the drawing with the turtle, and practice with more things that you can possibly find on the internet as well. Okay, so this is how you will draw a hexagon. Okay, if you don't use loops, right, what will happen is you will have to draw each and every edge. If you use loops, then you have to carefully write it such that you get the output of what you expect, right? Then if you want to create a spiral square, outside in and outside, inside out, okay, and if you want to do another user input pattern, there is an example that is given here, okay, and then spiral helix pattern, another example is over here, okay. So rainbow breeze. So take a look at all these things. So this is how you will draw with turtle. And if you want to draw colorful shapes in turtle, then links to that is also available here on the geeks4geeks.org website. Okay, so we have like t dot fill color and the color that we want to fill it with. Okay, and we can begin filling, and you can actually fill a closed object like this, like a square or a triangle or a hexagon, okay, or a star, okay, or a circle, etc. So I'm going to send you the links for that also over here. So that is what I wanted to cover completely today. So we have covered topics like object oriented programming, tell, don't ask, law of D meter, and single responsibility rule. Okay, that is where we started today's class in. And then I wanted to tell you that we will be learning two more concepts like graphics and images. So the graphics is with the turtle graphics turtle package, and images is with the Python imaging library. And we have learned about the pixel exit information, and then about the turtle package. So that ends all the topics. Thank you so much. Please practice. Thank you, Badraksh. Badraksh, are you still connected to the call? Hello, Badraksh.